These examples go with lesson 1.4, linear equations in two variables and linear functions. Example 1, graph the line represented by each equation. A, 4x plus 2y is equal to 2. The best way to graph part A is probably going to be to use the x and the y intercepts, because then we can graph those and then just draw the line in between them. Okay, to find the x-intercept, we need to put 0 in place of y, and then solve the remaining equation. We have 4x plus 0 equal to 2. 4x plus 0 is just going to give me 4x. And when I divide both sides by 4, I have x equal to a half. So the x-intercept is going to be at 1/2 and 0. To find the y-intercept, I need to put 0 in place of x and solve the remaining equation for y. 4 times 0 is just 0, so we have 0 plus 2y equal to 2. Well, 0 plus 2y is just going to give me 2y. And then when I divide both sides by that 2, we'll find out that y is equal to 1. That means the y-intercept is located at 0, 1. Let's look at the graph. All right, my x-intercept is at 1/2 and 0, so that's going to be about right here. My y-intercept is at 0, 1. That's going to be right here. So the graph of this line is going to do something like that right there. It should connect the two dots there. Let's try that again. See if I can draw a better line this time. There we go. And that's what our picture is going to look like for A. For part B, I'm going to kind of do the same thing. I'm going to graph this with x and y intercepts. Now, there is no x-intercept because, well, there's no x term over here. So, you know, this one has no x-intercept. And then the y-intercept, we would put 0 in for x, but there's not one, and then solve the remaining equation for y. It's already solved for y, so it looks like my y-intercept is going to be at 0, 1. When I draw the picture, I'm missing one of the variables, remember, so it's going to be parallel to one of the axes, and it's parallel to the axis of the missing variable. So since x is the missing variable, this line is going to be parallel to the x-axis. Now I'm going to graph my y-intercept right here, and then I'm going to draw in a line that's horizontal and is parallel down here to my x-axis. Well, for part C, to find my x-intercept, I would put 0 in for y, but there is no y. So let's just solve the equation for x, which is 3x is equal to 12. We divide by -3. We have x equal to -4. That means the x-intercept happens at -4 and 0. It will have no y-intercept because there is no y term over there. Okay, and because one of my variables is missing, remember, this line is also going to be parallel to the axis of the missing variable. So since the y is missing, this line is going to be parallel to the y-axis. We'll see what the picture looks like. All right, we're going to graph the point -4, 0. And then I'm going to draw a vertical line parallel to my y-axis over here. And that's all there is. Example 2. Find the slope of a line passing through the given points. A, the point -4, +1, and the point +2, -2. All right, our slope If we treat this one as x1 and this one as y1 and this one is x2 and this one is y2, then we will have negative 2 minus 1 divided by positive 2 minus negative 4. Well, negative 2 minus 1, that's negative 3, and 2 minus negative 4, 2 negatives make a positive, that's going to give me 6, and when I reduce this fraction, I get negative 1/2. For part B, again, if we treat this like x1 and this one like y1, this one like x2 and this one like y2, we'll have 17 minus 2 divided by negative 3 minus 3/4. And 17 minus 2, that's going to be 15. And negative 3 minus 3/4, that's negative 3 3/4. As an improper fraction, remember how to do that? You multiply 3 times 4 and then add that 3 right there. You're going to have 15 divided by negative 15 over 4. Okay, so now this is going to turn into 15 times negative 4 over 15 because we take the bottom fraction right here and we invert it, and now we multiply it by the top fraction there. And I can see that the 15s are going to cancel, so it looks like the slope for part B is just going to be negative 4. Example 3. Given the equation 2x plus 4y is equal to 8, A. Write the equation in slope-intercept form. Slope-intercept form, this is y is equal to mx plus b. So we need to solve this equation right here for y. Okay. So the first thing I'm going to do is I'm going to subtract that 2x over to the other side. This is going to leave me with 4y equal to negative 2x plus 8. These are not like terms, so I can't combine them. And then to get y alone, I have to divide everything over here by 4. And I like to divide everything individually so that I can see each of the fractions that I need to reduce. So y is going to be equal to negative 1/2 times x plus 2. Part B is asking us to determine the slope and the y-intercept. Well, the slope, which we denote with the letter m, you can think of m as mountain, that's going to be the coefficient on x. In this case, that's going to be our negative 1/2. The y-intercept, which has a notation of b, not sure where that one came from, that is the number that's either added or subtracted to our x. In our case, that's going to be our positive 2. And then part C is asking us to graph this. Now, if we're graphing with the slope and the y-intercept, we want to graph the y-intercept first, and then we'll move rise over run using the slope to get to the next point on the line. So we're going to graph 2. Now remember, this is a y-intercept, so the point I want to graph is actually 0, 2. That's right here. My slope is negative 1/2. Now, the negative either goes on the 1 or on the 2, not both. And I'm going to use it on the 1. So that means we're going to go down 1 and to the right 2 times, and that's going to give me another point on my line. And I do another one for good measure here. So we're going to go down 1 and to the right 2 times, and that gives me another point on the line, and then my line is going to look kind of like this right here. And since the slope is negative, my line should be going downhill, and it is. Example 4. Write the equation of the line that passes through the point -1, -4 and has a slope of 3. Then write the equation using function notation. Okay, since we're going to put it in function notation, we might as well write the original equation there in y equals mx plus b form. Because when we put it in function notation, we're going to take the y out, and we're going to replace it with a function name f, or g, or h, or q, whatever you want, of x, because that's going to be my variable over here. But I'm still going to have mx plus b over here. So essentially, these two answers are going to be the same, just one of them's going to be equal to y, and one of them's going to be equal to f of x. Okay. This I'm going to be treating like my x value. This is my y value. This is my slope. So the only thing I'm missing in my formula here is b, the y-intercept. So the first thing I'm going to do is try and figure out what the y-intercept is. Now I'm going to fill in -4 for y, 3 for m, -1 for x, and remember we're trying to figure out what b is. So we got -4 equal to -3 plus b. Let's add the 3 over here to the other side. That gives me -1 equal to b. So my y-intercept is going to be -1, or the point's going to be 0 and -1. When I put it into my equation, I'm going to fill in the slope that I'm given and the y-intercept that I just now found. And I'm going to leave the y as a y and the x as an x. So y is going to be equal to 3, the slope they gave me, times x, and then -1 because that was the intercept that I just now found. And then to put it in function notation, we said the function was going to be f of x, and then we're just going to keep the 3x minus 1 here. Example 5. A. Determine the average rate of change of blood alcohol level from x1 equals 2.5 to x2 equals 8. And we're going to round this to 3 decimal places. Okay. So the rate of change is pretty much just asking us to find the slope. The slope of the line that connects 2.5 to 8. All right, so that's going to be this point right here and this point right here. So if we can draw a line in here, let's see if we can do that. Okay, so I figured out how to make the ruler work, and I actually have my line drawn here, the green line. Now what we're trying to do is we're going to estimate what the rate of change is on the blue curve by finding the slope of the green line. And the green line goes from the point 2.5, 0.0095 to the point 8 and 0.02. All right, so if we treat this one like x1 and y1, and this one like x2 and y2, then our slope, or our rate of change, is going to be 0.02 minus 0.095 divided by 8 minus 2.5. All right, and we are supposed to round this to 3 decimal places, so let's simplify this a little bit. All right, 0.02 minus 0.095, this is going to be negative 0.075. And then in the denominator, 8 minus 2.5 is going to be 5.5. All right, so let's put that in the calculator and round it to 3 decimal places. And this is going to give me negative 0.014. It was actually 0.1366666, but the 6 is going to round that 3 up to a 4. So negative 0.014. Okay, now for part B, we're asked to interpret the results. Okay, all right, let's keep in mind that this can actually be written as a fraction divided by 1. Okay, and that the slope is actually the change in y divided by the change in x. Okay, The units on Y over here, this is our blood alcohol content in percent. And then the units down here on X, this is the time in hours. Okay, so something's happening every 1 hour because we have 1 in the denominator here. Okay, and what's happening has to do with the blood alcohol content. So our blood alcohol content is decreasing because the slope is negative. Okay, blood alcohol content is decreasing an average of how much? Well, that's what this number is for, 0.014. 0.014%, because that's the units on there. And we don't have to put the negative because we said the word decreasing, which means that that number is negative. And then per hour. So in math, the word per means division. And we have division right here. And then we've got 1. And remember, 1 was in hours. So that's where we got the per hour from. Example 6. Given the function defined by f of x is equal to x to the third plus 2, determine the average rate of change from x1 equals 3 to x2 equals 0. Okay, we don't have the graph to look at this time. And actually, we could pull up Desmos and draw the graph for it, and we could see what it looked like. But they're already telling me which two x values to use. Namely, I'm going to use x equals 3 and x equals 0. And in order to find a rate of change, which is just a slope, I need to have the y values. So the first thing I'm going to do is find out what y I get when I plug 3 into my function, and then what y I get when I plug 0 into the function. So let's do f of 3 is going to be 3 to the third power plus 2. 3 to the third is 27. 27 plus 2 is going to give me 29. That means this point is at positive 3, positive 29. Now let's try 0. We got 0 to the third plus 2. 0 to the third is just 0. 0 plus 2 is 2. That means this point is going to be 0 and 2. Okay, we've got 2 points. We can find the slope in between them. We treat this one as x1, and this one as y1, and this one as x2, and this one as y2. Then the slope is going to be y2 minus y1 divided by x2 minus x1. 2 minus 29, that's going to give us negative 27. 0 minus 3 is going to give us negative 3, and this fraction will reduce. 2 negatives make a positive, and 3 can go into 27 9 times. So the rate of change between x equals 3 and x equals 0 is 9.